And as I see here, you can do Simon's favorite factoring trick. And how do you do that exactly? Well, you move you move m plus n to the side, to the other side. So mn minus m minus n, which is equal to is less than 0. So we basically just did algebraic. We switched m plus n to the other side, which is just an algebraic expression. So, and how do you do Simon's favorite factoring trick using this? We're gonna do an example first with x and y. So x and y minus 5x plus 3y, which is equal to 0. And you're going to see here, how do you do Simon's favorite factoring trick? Well, as it says in the name, you're trying to factor. So x plus 3, y minus 5. And basically, how I thought about that is we have the same, when we expand, we have xy plus 3y minus 5x. And you'll get more used to it when you practice a lot. But when you expand, you see that it's the same. So you have this 3 and you align it with this y on the other side because you want to get 3y, and you have this negative 5 and you align it with the x on the other side, which you get negative 5. And as you see here, we aren't done because there's negative 15 that's still waiting to be multiplied in. And as you see in the original equation, negative 15 isn't there. So what do you have to add? What do you have to add to make sure that it doesn't exist? So it's the same as the original equation. You add 15. So negative 15 plus 15, which is equal to, which crosses out, which is equal to 0. So when you have this factor, when you have x, when you have x plus 3, y plus y minus 5, you want to add 15 because you know that when you expand, you have negative 15. So negative 15 plus 15, which is 0. So you have to add this 15 to make sure that you're not overcounting and undercounting for some instances, which is equal to 0. So that's this equation, as you see right here. This Simon's favorite factoring trick equation is the same as the first equation. And that's how you factor. And you can move negative 15 to the side, to the other side, which would equal x plus 3, y plus y minus 5, which is equal to negative 15. So right here, we can find all the factors extremely easy. Negative 1, 15, negative 3, 5, and on and on and on. That's how you do Simon's favorite factoring trick. So when we know Simon's favorite factoring trick, we can do it for this problem. So we can do m minus 1, n minus 1, and as you see, it's the same. When we expand, it's mn minus n minus m, and we add 1. And that's not, adding 1 is not in the original equation. So what do? Subtract by 1. So when we multiply, we expand, we have adding 1, and we have to subtract 1 on the outside to make sure that we don't overcount. So which is less than 0. Okay, since it's less than 0, we already know that this equation, Simon's favorite factoring equation, is the same as the previous equation. And all we're doing is knowing that we move 1 to the side, which is we're just adding 1 on both sides. So it's m minus 1, n minus 1, which is less than 1. And as you see here, we can just make sure that we can set one of these variables as 1. So we know that one of them is 1, and we can set, okay, so n minus 1 or m minus 1 could be equal to 0. And how we know that is that because anything multiplied, if m minus 1 was 0, and it's multiplied by n minus 1, we know anything multiplied by 0 is 0. And 0 is less than 1. So we can just know that if m was 1, that would work. If n was 1, that would work. And since, okay, if n is 1, then it would be 0 multiplied by n minus 1. That means m could be anything, because whatever m could be, it really doesn't matter, because it's just going to be multiplied by 0 after it's subtracted by 1. So, so it's just 0 times m minus 1, which is less than 1. So we know that anything multiplied, m minus 1 really can be anything, which means that it can be an infinite amount of solutions, and it still equals 0, which is less than 1, which satisfies the equation. So we have infinitely many solutions.